The broadcast is now starting. All attendees are in listen-only mode.
Good morning, and thank you for joining us for another webinar in regards to our ongoing municipal concrete paving webinar series. Today we will be discussing quite a unique road application, roundabouts. There are more and more roundabouts being constructed all over Ontario, and there are some major benefits over typical stop sign or signal controlled intersections. If you add on top of that the many benefits of concrete, you're going to end up with some very, very sustainable infrastructure and very aesthetically pleasing infrastructure, as you can see on your screen. That's something we will be showcasing today with two presenters. But before we do get to our presenters, as always, my name is Alan Carey. I'm the Director of Technical Services at Concrete Ontario, and I will be your facilitator. I figured I should change my picture to COVID times. So this is just a picture from one of our certification courses that we ran. In terms of housekeeping, for anybody new joining us today, this will be approximately a 45-minute webinar, and we will have questions and answers at the end. All participants are currently muted and will remain that way for the entire webinar. If you do have a question, please use the GoToWebinar questions pane on the right side of your screen and type in your questions, and we will address all questions at the end. The webinar is currently being recorded and will be posted on the Concrete Ontario website under Publications and Webinar Presentations, along with a copy of the PDF presentation. If you did miss any of our previous webinars, as I mentioned, this is an ongoing webinar series. You can access all the recordings and PDF presentations under Publications and Webinar Presentations on our website. So feel free to check them out and let us know if you have any questions. Now, in terms of the agenda, this is what it looks like for today. We're going to talk about briefly, why are municipalities and, cities around the world constructing roundabouts, just some general benefits. Then we'll get into the many sustainability benefits of concrete roundabouts. We'll briefly review some of the basics of concrete pavements, pavement thickness design tools, and jointing for concrete roundabouts. And then we will have a representative from the County of Essex talking about some of the projects that they have completed over the last few years. And at the end, I'll talk about some innovative pavement marking techniques that they have used. There are many resources when it comes to roundabouts, but one of the best ones out there is the Transportation Association of Canada, TAC, Canadian Roundabout Design Guide. It was published back in 2017 and does provide information and guidance related to the planning, design, construction, operation, maintenance, and safety of roundabouts in Canada. So this is a very good document. It has 10 chapters, and it is available on the TAC website for approximately $250. But I would encourage everybody to check it out if you are considering putting in a roundabout or if you do want more information. Now, in terms of a roundabout, I'm sure most people have driven one, but we just wanted to provide a general overview. So some basic components of a roundabout is you have your central island in the middle of the roundabout, and it can be a circle or it can be different shapes. And then you have your splitter islands, which separate the different lanes and separate traffic. You also have a circulatory roadway, so you're always traveling counterclockwise, making it quite easy. You're always looking left and you're always driving right. In the middle again, where the center island is, you have a truck apron, which allows larger vehicles to travel around the roundabout more safely and efficiently. When it comes to the actual lanes, you have an entrance line just over here and over here and over here, for example, and that's where you need to yield to oncoming traffic. You're always yielding if you are in the entrance ways, and you always have the right of way when you're actually in the roundabout. There's also pedestrian crossings, which are a little further back compared to a typical intersection. You have landscape buffers, and then you have the inscribed circle diameter over here. So overall, just some basic features and a basic overview of roundabouts just to give you an idea of how it all works. Now, in terms of why are a lot of cities around the world constructing roundabouts, Studies have shown that roundabouts are safer than traditional stop sign or signal controlled intersections. For example, the Insurance Institute for Highway Safety from the US, if you were to replace a stop sign or signal controlled intersection and install a roundabout, you can reduce crashes by approximately 75% compared to a normal intersection. So that's some pretty drastic safety numbers. In addition, studies by the IIHS and the Federal Highway Administration have shown that for roundabouts, you will see about a 37% reduction in overall collisions, 75% reduction in injury collisions, 90% reduction in fatality collisions, and 40% reduction in pedestrian collisions. So very drastic safety measures, making roundabouts a lot safer than your traditional intersections. Now, why are they that much safer? One reason is low travel speeds. So drivers must slow down and yield to traffic before entering a roundabout. And speeds are typically between 20 to 30 kilometers an hour. So if there are any collisions, they are happening at very low speeds, and there's typically only very minor injuries. Another reason why they're much safer is there's no light to beat. Everybody knows when the signal turns yellow, some people accelerate. There's the risk of T-bone accidents and head-on accidents. Well, that's all eliminated when it comes to roundabouts. You're yielding to traffic when you're entering the roundabout, and because traffic is constantly flowing through the intersections, drivers don't have the incentive to speed up and try to beat the light, which again eliminates a lot of worries for people. And finally, another reason why they're safer is it's only one-way travel. You're always looking left, you're driving right. The possibility for T-bone and head-on collisions is eliminated, again, making it a lot safer. Some other additional benefits of just general roundabouts, they do reduce delay and improve traffic flow. So a lot of people think that actually, contrary to people's perception, roundabouts actually move traffic through an intersection more quickly and with less congestion on approaching roads. Because they promote a continuous flow of traffic, they also reduce idling. You don't have cars actually stopped, they're always moving. And for example, a study by the Kansas State University measured traffic flow intersections before and after conversion to roundabouts. In each case, installing a roundabout led to a 20% reduction in delays, and additional studies have shown that roundabouts contribute to an 89% reduction in delays and 56% reduction in vehicle stops. So overall, you are eliminating a lot of emissions simply by putting in a roundabout. Roundabouts are actually less expensive. So the cost difference between building a roundabout and a traffic signal is comparable. Again, these are numbers from the US. But when you're looking at long-term costs, for example, maintenance and electrical costs associated with traffic signals, they can be anywhere between $5,000 to $10,000 per year, which you would eliminate by installing a roundabout. And finally, a roundabout does need less space. So even though the actual property within the actual intersection does need more space, all the approaching roads need a lot less space because you're not going to have a lot of cars backing up like you would in a typical intersection, meaning traffic is continuously moving and you need less space in that case. So that's just a general overview of roundabouts. Some really good facts there in terms of safety. But moving on, we'll introduce your first presenter. A lot of people are already familiar with Tim and myself, but Tim has been in the industry for over 25 years. He worked for Lafarge, the Cement Association of Canada. He was with Englobe designing concrete pavements, and now he's back with the Cement Association of Canada, working on all sorts of pavements across Canada. So good morning, Tim. How are you?
Good. Thank you very much, Alan. Doing very well. Hope everybody is keeping safe.
Great. So I'll turn over controls to you, and you can get us started in terms of the concrete benefits and just general design.
Okay, thank you very much. See if it works. It's not advancing yet. Oh, there we go. Great. So when we're looking at concrete pavements, not only can it handle the slower speeds, the heavy weights, and the sharp turning movements, but there are a number of other sustainable benefits that we thought would be very beneficial to look at, because they may actually help you when you're going through your analysis on your pavement type selection on what are some of the other benefits that you might be looking at. So one of the things we know from concrete pavement is it has better fuel economy. Now, if we're looking at just a specific concrete roundabout, you're not going to see fuel savings because it's such a small area. But if you have concrete roads going into it, you'll continue to get those fuel savings. Another thing is less fuel consumed during construction, because a concrete pavement actually has a thinner pavement structure, and that's due to the way it takes loads. There's less granular material being placed. So you'll have all that fuel savings from not having all the movements of the trucks bringing the aggregates back and forth to the job site. Another thing you have is you can use recycled material on it. You'll have blast furnace slag or fly ash can be used in the concrete so that you can have better properties for it. And it actually stabilizes that material in place, so it makes it inert and prevents you from having to take it to a landfill. Another thing you have, oops, not advancing. My screen's locked again. Oh, there we go. Another thing is light reflectance, and I'll have a slide on this in a second, but concrete provides a better way of reflecting light than the dark surface of an asphalt does. Next is enhanced riding comfort. We don't have the rutting and the shoving that you would definitely get in your potential to have that at a roundabout, because you get those shear movements, the turning, sharp turning movements, and putting a lot of stress on your pavement. We also have innovative pavement surfaces you can put in now. There's longitudinal tining, there's grooving of the concrete surface as well. You can put the surface texture that you're looking for, the burlap drag that you put for helping in the skid resistance, and less non-renewable resources and lower energy footprint, because the main binder in asphalt is actually liquid bitumen, which is a feedstock energy. It has a higher energy footprint than the concrete does. So what else can we look at? Well, we can look from a safety point of view. You have a reduction potential for hydroplaning. There's two types of texture that you put in your concrete. Because it's in a plastic state at the start, you can actually put a tining in it, which is the macro texture. That actually allows you to have a groove for water to go into when a tire goes over top of it and there's water and it's raining. So it actually increases the pavement tire interface so that you reduce your potential for hydroplaning. Another thing that you have is your microtexture, and your microtexture actually comes from the sand and the burlap drag or the astroturf drag that you do in your concrete. So that provides you with your skid resistance. And if you have a higher amount of siliceous content, it provides you with good skid resistance and actually lasts longer by having that siliceous content in it. Next thing is when we're looking at light reflectance. And what I wanted to show here, I don't know if anybody is older like me and looked at Columbo, watched the movie, this is a guy showing the light reflectance of an asphalt versus concrete. And what the key thing is here is asphalt reflects light in a specular manner. It's kind of like taking a ball and throwing it against the floor. The ball will bounce up at one angle, so your angle is reflected towards you. Concrete, on the other hand, has a diffuse manner when it's reflecting light. It's like taking a ball and throwing it into water. You throw it in water, and the water splashes up at all angles. So you get a better light reflectance because of that. This allows you to have better night visibility, or in a case such as the Maritime Ontario RCC job that was done several years ago, they actually decreased the lighting that they put in the perimeter of the site and the lights that they put in the outside at the loading docks, because they believed that the light reflectance was better and provided them the ability to reduce that lighting. Another thing, concrete pavement is totally recyclable. You can actually reuse the steel, either reuse the concrete in as a base for your a new roadway, or you can actually use it back into the concrete itself if it's produced to the appropriate specifications. So now we'll go back into a little bit of the basics. I'm not sure how many people would have been attended their earlier webinars, but because we're not sure who is attending, we're going back and doing a little bit on some of the basics of concrete. So what are the key things to take out of this slide? The dowel bars and tie bars are very different types of products. Tie bars are put at the longitudinal joint, as you can see along here. They're used to actually keep the concrete together so that you will not have the concrete drifting apart if there's no restraints on the ends of it and have yourself a maintenance problem. So they're cylindrical, but they have a ribbing on them, and it allows the concrete to bond to it, so it prevents the concrete adjacent to it from pulling apart. Dowels, on the other hand, are round. There's no ribbing on it. They have a tactile material that actually allows the concrete to not bond to it, so that as the concrete expands and contracts in the transverse direction, that you'll end up having that load transfer across the joints, so that you have good load carrying capability for your heavy truck traffic. Longitudinal joints, as mentioned, goes in the direction of traffic. You'll have to do that on your concrete to ensure that you don't get a meandering crack in the middle. And then you want to put joints in at a specific distance based on the amount of traffic that you're having and the thickness of the concrete that you're dealing with to control the random cracking that will occur in the concrete. And I have a few slides on that to explain that in a little bit when we go into the jointing. Then underneath concrete, you'll normally have a base. Sometimes you'll have a base and a sub-base both. The next slide, excuse me, please. The slide here is what I'm trying to show is the difference between the load, the way concrete and asphalt take loads. Concrete takes a load, and most load is taken within the concrete itself. A small part of that load is then transmitted down into the base and sub-base, so the pressure down in the subgrade is very low. It's a rigid system. Asphalt, on the other hand, is what's called a flexible system. The asphalt transmits the load down from the asphalt, down into the base, down into the sub-base, actually down into the subgrade. So the whole pavement structure is very key to the asphalt, and that's why it requires more granular material than a concrete pavement does, because of that way it's taking the load. So load transfer is extremely important in a concrete pavement because you don't want to have the slabs acting as individual slabs. Because what happens when you lose your load transfer from one slab to another, you'll get rapid pumping of those slabs as the weight goes from one slab to another. And what it can do is take the fines that's in the granular base underneath, pump those out, and you'll get faulting of the concrete. So to prevent that from happening, what we do is we use load transfer devices, the dowels. They're cylindrical. They're usually in the 32 to 38 range, and that'll all depend on the amount of traffic that's being carried. Sometimes we'll actually, when we have a 175 millimeter pavement that we want to use dowels in, we use the smaller dowels, 25 millimeter dowels. Basically, the rule of thumb is when the pavement is 200 millimeters or more, you usually would put a dowel in it. One dowel, the dowels will actually be able to reduce the thickness of your pavement, usually in the 25 to 40 millimeter range by utilizing the dowels. So when we have concrete, we want to make sure that we have a good product. And one of the best ways to do that is ensure that you follow OPSS Muni 1350, looking at the batching plants. And what we have is certified plants, batch plants and equipment are certified by the Ready Mix Concrete Association of Ontario, which is now called Concrete Ontario. They will actually go through and ensure that the ready mix trucks have the appropriate fins are clean. They go through and look at the batch plant, make sure everything is operating functionally and properly, and then they'll be certified. To get a list of that, there's a URL here that you can follow to go and look at what plants have been certified by the association. But again, it's critical for the durability of the concrete to ensure that you have good quality concrete, and having certified plants is one way to do that. Next thing is municipal specification requirements. What are we looking at? Well, for the Muni, OPSS Muni 1350, it's a key one. And within that, we're looking at the performance requirements for concrete under section 5.02. And then we want to look at the reference to CSA 23.1, the 2019 version. It's extremely important that you follow CSA to ensure that we have quality concrete. And I have a slide on that shortly. So here we are. When we're looking at concrete pavement, we're a class C2 exposure, non-structurally reinforced concrete exposed to chlorides and freezing and thawing. When you go to CSA, you then can look at, for that class exposure, what is the maximum water cement ratio that should be provided? What is the minimum strength specified? And it specifies 32 MPa. And then what is the air content category? It's 1. So when you then go to the air content category, you then look at the maximum size aggregate. Your maximum size aggregate will tell you how much percentage of air you'll need. When you have larger size aggregates, you'll have less paste. So, you know, for the 20 to 40 millimeter aggregates, you have an air entrainment of only 4 to 7%, because you have less paste, and less paste means you don't have to have as much air entrainment. When you have the smaller size aggregates, you want to bump that air up so that you can have a durable paste within the concrete pavement mix. So now that we've gone over really the basics, we want to look at when we're doing pavement design. And there's a lot of different things that affect our design. One, you look at your climatic conditions. What's it, freeze-thaw conditions that you have? Are you wet-dry? Are you an area that has a lot of precipitation? So you have to look at where you are in Ontario to decide what is the best data to be using. You have to look at your materials. I have to go through and I have to test my materials for ASR. You have to look at doing decracking tests. You have to look at the coefficient of thermal expansion. What is that? If you're using the ASHTO ME procedure for the design, there's a lot of data that you have to get. So the material data is very important in the design. Another important thing is the loads. What type of loads are you handling? Are you taking single axle trucks? Are you looking at dual axles? Are you looking at tridents? Are you looking at a combination of all the above? And what's the frequency of that traffic? All of those will cause the materials, the climate, and the load together will cause a response to your pavement, and you get accumulated damage over time. So then you have to look, okay, what is the length of time I want to design my pavement for too? So there's a lot of different aspects that you look at. So these are the key factors that I look at when I'm doing a concrete pavement design. You want to look at, as mentioned, the expected truck traffic. What are the weights? What's the frequency of the traffic? What types of loads are you looking at? And how are you carrying overloads? Design features. Are you going to be using dowels? Are you going to be having edge support? Edge support will actually affect the thickness required, because if you're within a half a meter of the edge of your pavement and there's no support, then the pavement thickness has to be increased to take that into account. Reliability. Are you looking at this as a county road? Are you looking at this in a major intersection? What is the amount of reliability that you require on that pavement? Then you're looking at the properties. What flexural strength are you going to use? MTO uses a flexural strength of 5 MPa. All concrete pavements, although you specify in CSA the 32 MPa, it's a flexural strength that you're designing the pavement to. So what is the flexural strength, and what is the corresponding modulus of elasticity that you're utilizing for your design? Then you got to look at your support conditions. What type of subgrade do you have? How much granular material is going to be under your pavement so that you can do an effective K-value calculation? All these things are taken into account. And then again, what is your design life? Is it going to be 20 years? Is it going to be 30 years? Or is this just a temporary that you're going to be utilizing this and then you go to a shorter lifespan? So what are the pavement, different types of pavement software out there? The most sophisticated, but also most expensive system is the ASHTO Pavement ME. This is a very sophisticated, even a forensic evaluation type of tool that you can use to come up with your pavement design. But it does require a lot of inputs. So you have to know things such as Poisson ratio, your coefficient of thermal expansion. You need to have extremely good truck traffic data. It's a lot more complicated system, but it's a great product if you have the data to fit into it. There's also the lower level ones, such as Street Pave, put out by the American Concrete Pavement Association. This is a very good program that requires a number of data inputs as well, but not near as much as the AstroWare ME, and it provides you with a very good analysis. And what I normally do when I'm doing a pavement design, I use at least 2 different softwares or processes to come up with my design so that I can make sure that what I've done on one program is good. ACI also 325, 330 have tables that you can refer to in the design. There's also now free software called pavementdesigner.org, and I'll have a slide on that shortly, that can be used too. And if you have a situation where you want to use an older program, the WinPass program is based on the Astro 93 design procedure. You can actually use that to back calculate your asphalt design, to use your asphalt design to back calculate what your design should be in a concrete design. So there are a lot of tools out there for you to use in the process. And we actually are going to be having on December 4th, I believe, we're going to be having a pavement design webinar, which will go over the various software in a little bit more detail and actually specifically show some examples of how to use a pavementdesigner.org. And pavementdesigner.org, it's actually it's a combination of a lot of different software. It takes the Street Pave software so that you can use it for on-road vehicles. It takes the Air Pave software so that you can use it for off-road vehicles. And it incorporates the WinPass procedure in it as well. It takes the procedure that's used by PCA to come up with your design, and also allows you to use the NRMCA design guidance in sustainability and asphalt design evolution process. Another thing that you can actually use for a quick reference is the Cement Association of Canada had hired ARA to go through and do an equivalent pavement design process where they looked at different strengths of the subgrades, values of 30, 40, and 50 MPa, and then different levels of truck traffic on the pavement, and to develop what the Portland cement concrete pavement design should be and what the hot mixed asphalt design should be. So this just gives you a rough guide of, if you're looking at doing an asphalt design, you can actually look in this table and get a rough estimate of what your concrete pavement design should be. But I would always go through and back and do a design using the Street Pave 12 or the AstroWare ME so that you can ensure that the design that you're picking is the right one. Because every job is a little bit different. You have different environmental conditions, different strengths in your subgrades. So this is just a small range of the subgrade strengths. There could be a different range that you're dealing with. And finally, on the design side, there's also ACPA has a publication for design of concrete pavements for city streets. And in that, they recommend some ranges of pavement thicknesses for, depending on what class of street you have and the amount of traffic on it, they suggest some range of thicknesses and dowels, whether dowels are needed. So this is another one that you can actually do a quick check on. And then you can also use the ACI 330 and 325 as well as a check on your software that you're using to do your design with. Just remember too, when you're doing your design, you've got 2 roads coming into this. So your center circle will have a different traffic level than the roadways coming into it, because it might be taking traffic from both ends, depending on what the movement and flow of traffic is. So consider that in your design as well. So when you're designing your concrete, one of the key things that you have to know is that concrete will shrink. If it was on ball bearings and when it's first placed, it's at its maximum water cement ratio. So as the hydration process occurs, you're going to start losing some of that water. It'll evaporate out through, or it'll be used in the hydration process. So your concrete's going to want to shrink. As the concrete, the cement particles are hydrating, there's a meniscus forms into them. There's surface tension there. And as that surface tension increases, it at one point will be stronger than the concrete is at its early stages. Because of that, it'll actually cause a crack in the pavement. So to prevent that from occurring, what you're going to want to do is you're going to want to joint that pavement. Now, the joint in the pavement is usually from 4.3 to 6 meters is the standard joint spacing that you do in a plain jointed concrete pavement. And again, the profile here shows when you have a thicker pavement, it is usually a good idea to use dowels to ensure that you have that load transfer across the joint and provide you with a pavement that's not going to pump and then fault over time. This is just a close-up picture of a good performing joint. You see that the joint was cut, and you can see the crack that has occurred at that joint. So that shows you that this joint has performed well. The one on the left-hand side. The one on the right-hand side actually shows you this would have been taken later on in the season, and you'll see that the joint's opened up quite a ways. If you didn't have dowels across this joint, what you have is no aggregate interlock. So you would have a rock in your panels. So it's necessary to have those dowels in there for your thicker pavements to ensure that you have that load transfer. It might also indicate that there might be a few joints that have locked up and you've got more movement in this slab itself. So again, having the dowels at the joint provide you with a good performing concrete pavement. Now, when you're doing jointing, there was a great presentation yesterday by the American Concrete Pavement Association on concrete roundabouts. It very much focused on jointing the pavement. So, and it was an hour long. So instead of me trying to go into detail on that, what they did is they have a 6-step process that they go through, from identifying where the edges of the pavement are, identifying what type of jointing process you're going to use. Are you going to use the flow through, or are you going to use a circular process? And I have a couple of slides to show you on that. You want to look at the transverse joints within it. Remember, it's the radius of the curve, so you're going to go from the center of the where the pavement would be, and move the joints out from that. And it's, like I say, it's a very good presentation put on by HCPA. And so instead of trying to go over that in detail, we've got a link here that we're going to show you of how to get access to that presentation. And here's the information. So you'll have that when you go to our website and download or look at the presentation again if you want to. But there's the link to the presentation by the CP Tech Center, Concrete Pavement Technology Center, and the American Concrete Pavement Association, the webinar that they did yesterday. Now, I mentioned there's 2 types of roundabout designs. There's more than 2, but the 2 most common types. And these actually will be the 6 steps that I mentioned earlier are actually in the TAC guide. It lays out that process. And then you also have pictures of the isolation where you're doing a circle and your joints emanate from the middle and go out, radiate from the middle of your diagram. You put an isolation joint around here so that this circle here is totally isolated from the rest of the pavement, and it gives you that expansion and contraction capability of the middle concrete so that you don't have any issues with the concrete, this concrete butting up against this concrete. Very good way of doing it. It's a very common process that's done. And then you address your jointing on the other areas based on the geometric design of this area. The next one is the flow through. This is actually a little bit quicker to do because you can actually use a slip form paver, slip through here, do your run through. You put your isolation joints here to ensure that this pavement here, which is going to be moving this way, and this pavement moving this way, do not come in contact with each other. So you isolate those areas here, on all 4 sides there. And that way you'll actually have, it's a little bit quicker, and some contractors like to use this way. There's a pinwheel process too, which actually is explained in the ACPA presentation. So I would recommend highly, if you're very interested in concrete roundabouts, and specifically just the jointing side, that you go and take a look at their presentation. Another thing that you'll find, and there's a few additional ones that were provided in the TAC guide, but this is from the OPSSD from MTO, and it shows you the isolation process for your manholes and for your catch basins. And there are different designs that you can do. Sometimes they'll put reinforcement in along here to, we know that there may be a crack occurs here, so they'll put reinforcement on there to ensure that that crack does not transfer or emanate any further than there. But the TAC guide, I believe, has 6 different diagrams in it. I'm only showing one. So what are the key specifications that you should be looking at on the OPSS side? OPS 350 is the construction specification of concrete pavements and concrete bases. So that's a very important one to make sure that you look at that. You also want to look at your construction specification, the 314, 501 looks at after construction specification compaction, and the 350, of course, is material specification for concrete materials and production. All key specifications that you should get familiar with if you're looking at doing concrete roundabout. Let's see, you can go to the next one. Oh, one last one before we go to Peter. Then there's the OPSSD, Ontario's provincial standards, the drawings. There's a number of drawings on there. I just picked out a few. There's concrete composite pavement utility isolations. There's the concrete pavement joint details. You can look at barriers if you have in it, and wide gutter. So there's a lot of diagrams in there that you can go to, reference, and utilize in your concrete pavement design. So with that, I'd like to hand it over to our next presenter, Peter.
Thank you, Tim. I'm just going to introduce Peter. Thanks for that great overview. So our main presenter from the County of Essex is Peter Bziuk, and he's the Manager of Design and Construction for the County of Essex. He earned 2 engineering degrees from the University of Windsor, his undergraduate degree in civil, and his master's degree in environmental engineering. He started designing concrete pavements for the city of Windsor in 1990 and has worked for the County of Essex for 12 years. Good morning, Peter. Thank you very much for sharing your expertise with us this morning.
Well, good morning, Alan, and thanks for having me.
We really look forward to your presentation here. So I'll just give you controls here, and then you can start us off.
Okay, wonderful. So while you're just taking care of that, I want to thank Concrete Ontario and the Cement Association of Canada for inviting me to participate in this webinar. And as we go through some of the slides, you'll be looking at various photographs. And I want to give credit to Orston Consulting, which evolved into SEMA. It's mainly their design that you're looking at. And as Alan mentioned, I'm the manager of design. And the most proficient way for me to manage the design is to hire experts who know what they're doing. And that's where the designers at Orston and SEMA have played a vital role in making these roundabouts successful. So one of the main projects is the intersection of County Road 22 and County Road 2 in the County of Essex. It's in the town of Lakeshore. And this is an interesting one because, as you see, it's 3 legs. The 4th future leg to the left is subject to development, and back in 2012, 2013, we were going through the design, and the developer really wasn't ready. So we proceeded with a 3-legged roundabout, and I'm going to talk about a few different features from both a design perspective and construction perspective that lend themselves to this roundabout. So when we look at some of the details, County Road 22 itself is a main connector, arterial highway really, between the town of Lakeshore and the city of Windsor. So you look at your daily traffic, over 33,000 and growing. And obviously we wanted a design life of at least 20 years. Actually, let me just go back one slide. So you see the leg to the right, that's County Road 2. And prior to the design and construction of this roundabout, anyone who came off of County Road 2 trying to make a left-hand turn was basically taking their life in their own hands. There were motor vehicle accidents there. It just was not a fun place to drive, right? So when we look at, how many times we want to work at this intersection, well, really once in our lifetime. And we do expect with concrete to achieve far more than 20 years. The concrete thickness, 220 millimeters. We were aiming for 32 megapascals on our compressive. It is reinforced concrete. You'll see that in some of the photographs. It has the 32 millimeter low transfer bars, and then we have the tie bars also for stitching together all the concrete, right? It has a longitudinal timing, and then the joint spacing, of course, that varies, and I'm going to talk a little bit about joint spacing. I actually have a different roundabout, but nonetheless, the joint spacing is tricky at a roundabout, I will admit, and you need to go through the experience of it to really appreciate having a little bit of thought on how the jointing lays out. And again, this particular was designed by Worston Engineering at that time, who have morphed into SEMA, and it was constructed by Coco Paving in 2014. So here we are 6 years later, and we're getting good performance out of the roundabout. So if I start with the photo on the left, this kind of shows the fly-off lane going towards County Road 2. And again, you can see there's a low transfer basket that run longitudinal for the longitudinal pavement. And then, of course, we have the tie bars. Right? So I don't want to get into the details too much of concrete design, but generally speaking, if I ever see low transfer bars in both directions, the longitudinal and perpendicular, that's not a good idea. You're going to get unwanted cracking. So you have to be careful on how those baskets are laid out. And this piece here on the left, this was an infill. You can see the timing on the concrete on the left side had been completed. And then the photo on the right, that shows the finished product after it was opened up. And again, we have the skip lines. You can see just on the right-hand side, there's a mountable curb, and then there's a truck apron. So clearly when the rear tires of a 55-foot long truck, they drag their tires across here. And then, of course, for the incoming traffic, there's a few key design features. We have a gore area that is basically shared, depending which lane a truck is in, right? And then also we have the yield blocks, which I'm going to talk about in a little more detail as we go through the slides. So again, the joint layout can be a little tricky, and this is also a project which is under construction right now. This was designed by SEMA. This photograph was taken yesterday. The timing of the webinar worked out pretty good with what we have going on out in the field. And in the previous slide that Tim pointed out, where it had your two options on your joint layout, in both of those you'll consistently notice that the joints go back to the corners of the splitter island. So you can't go right to the corner because that kind of doesn't make sense. But basically what you'll find is with the construction of your bullnose, you end up with a fixed point, right? So whether you're looking at the bullnose on the left or the right, you have a fixed point where you've cut a control joint in your concrete curb, right? And then basically you need to find those points during construction in order to figure out how that lines up, right? So you can see here how the joint was the joint layout was painted. This is sitting on an open graded drainage layer, but basically the joint layout was painted, and then it would I didn't show you the bottom of the screen, but basically off the screen here, off the photograph, would be the center island, right? So as a rule of thumb, if you're looking at a pavement thickness in that 220 millimeter range, you probably don't want any more than 15 or 16 feet from these two joints, right? Anything larger than that, you could end up with cracked panels, and clearly you don't want that, right? So when we look at a roundabout constructed in asphalt, which we also have here in the County of Essex, this roundabout on the left is at the intersection of County Road 8 and County Road 23, just outside the town of Essex. And this was also designed by Orston in 2010. And this was constructed using asphalt for a couple different reasons. It was an infrastructure stimulus funding program. There was a timeline to get all the work done, and the asphalt seemed to be the faster way to go. However, even in the photo of the left, you can see scales of gray, right? And those are stress marks in the asphalt. And then when we look at the photo on the right, you can see the aerial with the black pickup truck, and you can see the edge failure, right? You start to see this alligator cracking, which is not stopping, right? And clearly that's a bit of a problem, right? So we actually in 2010 constructed 2 roundabouts with asphalt, and you have to look at the side friction of vehicles that cause that stress, right? So this is the other roundabout. This is at the intersection of County 31 and Road 3. It's a border line between the town of Kingsville and the municipality of Leamington. Leamington is to the left of this photo, and Kingsville is to the right. And again, you can see all the distress in the asphalt, because again, you've got a lot of turning movements, you got a lot of side friction that's happening. Even though it's a yield sign and people will generally roll through it, I like to call this the legal rolling stop. You know, you got that yield sign. So basically, there was a decision made to reconstruct this roundabout with concrete, and unfortunately, we had to do that after only 8 years. So when we go to this this photograph, this is during the reconstruction. So by now, we've taken out all the asphalt, and we're in the process of putting in our concrete. You can see this sea of baskets. You see the tie bar baskets. You see the load transfer baskets. Now, one of the tricky parts about this is that when this was originally constructed, it was for asphalt. So there really wasn't a lot of thought put in on where your joints are, your saw cut here in your curb. And unfortunately, these saw cuts do not line up with saw cuts over here, right? So during this process of reconstruction, we could only really satisfy one side. We lined up the load transfer baskets. It appears to be with the curb on the left. And then we kind of had to roll the dice. But I have to admit, I drive through this one once in a while just to kind of check on it. And we have not seen anything, I'd say, detrimental or showstopper with this curb on the right-hand side. Right? The other thing too, which is a little debatable, but I believe there's again, going back to the TAC guideline that Alan was referring to. When I look at this photo on the left, again, we have the curb for the splitter island, and then we have the mountable curb here, and then you have your truck apron. So when the asphalt roundabout was constructed, well, there's clearly no tie bars on that mountable curb. And there were no tie bars on this side either. But the tie bars were drilled in to the splitter island curb. Basically, a decision was made not to put tie bars in the mountable curb because we knew we already had tie bars in behind the curb, right? So this is where you kind of have to put a little bit of thought as to how that concrete is going to expand and contract. And being a radius, it's probably not going to contract at the same pace as your truck apron. Your truck apron is also thicker. So basically, in this case here, we actually went against the guideline book, and there are no tie bars, right? But you do see there's a bond breaker here that's laying on the stone, and that was pushed up against the concrete to prevent cracking of the concrete curb, right? So again, you see all of your 32mm load transfer bars, and then in the perpendicular direction, you see your tie bars. So again, in this case here, if I saw a load transfer basket along this this middle line, that's clearly a no-no. You don't want to do that. If you ever see load transfer baskets perpendicular to each other, you have to get rid of one of them. Otherwise, you will get a cracked panel. It just doesn't want to move for you that way. Let's see. So here we are, we're under construction, and the concrete, the photo on the left, they're placing the concrete, and it's coming along nicely. You can see all the paint marks that were on the stone to show the proposed joint layout in order for us to check it. And we did make several modifications. We had to tweak a few things in order to get things to really work properly. And then, you know, even though we're in an engineering field here, and we have a lot of standards that we go by, we have a lot of guidelines that we look at, we don't usually get the opportunity for innovation. But this was a little pet project that I had taken on several years before we actually constructed these roundabouts. And what it comes down to is putting down line paint, putting down markings, and not seeing them get chipped away by snow plows and various vehicles. So what we basically did here on this photo on the right is you see the outline of the yield blocks. And this happens to be an etching product, right? Very similar to what someone might use in their driveway. You see these etched driveways with exposed aggregate. So it was very simple. We had a little plywood form with a rectangle cutout that was the size of the yield block that we needed. And then we sprayed the etching compound in, and afterwards you power wash that off. And then when you put in your paint, you're basically filling in that rectangle. So what's nice about this is that now the concrete pavement and the paint are all at the same plane. You don't have a bump, right? And likewise, the snowplows don't take it off. So this was at 31 1/3. So when we go back to County 22, we needed arrows, right? That is one of the interesting features that I find about roundabouts is that at a single lane roundabout, you actually don't require marking arrows. At a 2-lane roundabout, you do, right? So again, going back to County 22, we started off with this photo on the left. The county operations crew was very willing and cooperative. They did a great job. You will see there's a number of pieces of plywood here. This is about 16 feet long from one end to the other. And you know, they numbered all the pieces for me so I could put together my puzzle, okay, and create the markings that we needed. So in the middle photograph, you see after the etching compound has been put down, okay, and then my operations crew comes in. They start putting together the pieces of the durable paint, and they have their process there. And then, oops, sorry, a little too fast. Let's get that one right. There we go. So then you look at the tips of the arrow, nice and clean. They throw the blowtorch on it, and at the end of the day, you have your marking, which again is at the same plane. It's the same surface as your concrete, right? For anyone who's ever really looked at you know, any intersection, you usually see arrows and they're chipped away, and They don't look very good after a few years. Now, in this particular intersection, County 22, one of the main objectives at the beginning of the design was to have minimal maintenance. So our operations guys really thought this was a great idea here, because they don't want to go out and play with 33,000 ADT trying to reestablish these markings. Okay, and then when we again go back to the final product. So you see the I'll look at the photo on the right. These yield blocks were also etched in, and they're perfect. Here we are. These two photos here were just taken earlier this year. So here we are 6 years later. The yield blocks have not been touched up at all. They're in perfect condition. And although I don't really have a photo of the arrow, it is back on the first introductory slide. Those arrows also are in perfect condition, right? The other thing you notice here, getting a little bit fancy, but a lot of compliments on it, is you look at the center treatment of a roundabout. I've seen some roundabouts where they put a little statue, there's trees, there's some landscaping. In this case here, again, because of the volume of traffic on County 22, we had a strategic decision to do as little maintenance as possible. So this is synthetic turf. And again, the synthetic turf is appealing to the eye. After we were done, we had a lot of compliments come in. People were asking, like, why don't you do this more often in other locations? It just made sense on a number of different fronts. So again, a couple little innovative things that we did there, right? Now, there is some technical information. Now, Alan, I know we're supposed to end at 11. Do you want me to run the video? We did take a video during construction.
Yeah, I mean, we can run through it quickly just to give people an overview of what it looks like when you're actually constructing it. I don't know if we can watch the whole thing, but you can kind of fast forward through it. So 1 second here. Are you ready to show it?
While Peter's bringing that up, I just wanted to bring a comment. It's Tim here. One thing that Peter mentioned about, he has joints at different locations on both sides of the with the curb. If you want to take one curb and use that as a guide, and your dowel bars go there, you can actually isolate the other curb so that there's no chance of those joints in that curb jumping into the concrete pavement and causing some cracking issues. So there is a way to get around that by doing isolation joints on one side if you don't have matching locations for your saw cuts on your curbs.
Mm-hmm. Yep, good point. So again, one of the things that we look at on County 22, one of the early on objectives, whoops, I hit something here. Show my screen?
Yeah, you should be able to show it. There you go, perfect.
Okay, is that better?
Yep, looks good. You can play it.
Okay, so one of the early objectives was, how do we keep traffic moving through this area? And again, County Road 2, which heads off through a residential area, it was decided it's not desirable to send 33,000 ADT through that area. I mean, my phone would have been ringing off the hook, and we all know we don't want that. So basically, what we did here was we constructed a temporary asphalt road, and then you can see the Jersey barriers, which isolates the construction area, right? So let me just keep moving a bit. And as we go through some of the various seasons, we had this video camera at the top of a hydro pole, so we had a pretty good perspective. And again, you can see the traffic is moving. You'll start to see some construction activities, earth moving. They start to get into the sub-base granular materials. One of the other things that I really insisted on when it came to the construction of this roundabout was a single lane paver. For those of you who have worked with concrete and you've been on a project where a double lane paver was used, you can do that. The tricky part, in my opinion, is saw cutting the longitudinal joint, because basically you've just put down 2 lanes of concrete and you need to come back and saw cut the skip line. And if you don't do it in time, you could end up with longitudinal cracks. So again, in this case here, we wanted to have as minimal maintenance as possible after we open. So there you go, you see a single lane. I should stop for a second. So you can see how there's a single lane of concrete which has been constructed, and there's the single lane paver sitting there right in the middle of the photograph. Now, the thing too that we did, which we were willing to pay for, we wanted excellent quality in our concrete, rideability. So after the concrete single lane paver went through, a gang drill was used to drill for the tie bars. You can see all the concrete dust sitting right there, right, both sides. We did not want any deflections in the concrete when a tie bar is just pushed into the concrete, right? So again, we were going for maximum quality on this one. So again, as we just let it roll, you start to see more construction.
And Peter, you should note that's on an open graded drainage layer.
Oh yes, sorry, that's true. So again, part of the design of this roundabout is the concrete is on an open graded drainage layer, which basically consists of clear stone with a asphalt cement coating. So that's why you see the black layers going down ahead of the concrete. That's not asphalt per se. It's the drainage layer, which has the asphalt cement on it. Right there, you see the synthetic turf going in, and the light standards. Now, one of the things we're going to do here, and as it rolls on, we actually, when we get to stage 2, we run the traffic through the roundabout the wrong way. In one direction, it's running the correct way, but in the other direction, it's actually going the wrong way. But the thing is, we needed to do that on a temporary basis in order to move on to the other side of the roundabout, because we want to get rid of that temporary asphalt road. We need to be under construction in that area where vehicles are currently driving. And then at one point, we actually did close County Road 2. It just was inevitable. So now you can see the vehicles. I'll stop it for a second. Yeah, so you can see the vehicles that are heading, this would be eastbound. They are in the correct configuration. That's normal. The vehicles that are heading westbound, they're actually going through it backwards. They're kind of making the right and then a sharp left over here. But again, that was part of the objective, is to keep traffic off of County Road 2. So again, you see the single lane paving. Sometimes it's short strips like that, but again, it's to line up with the wheel blocks. A lot of infilling going on. I just let it roll for a bit.
There's no, in 6 years, there's been no maintenance done on that concrete at all.
Right.
Compared to the asphalt was replaced in 8 years. Asphalt roundabout.
Yeah, and the other one, the 31 and the 3rd.
Yeah.
Yeah, it's unfortunate, but we had to do it. Oh, there you see the arrows going down at the bottom of the video. So again, the tricky part about the arrows and the etching is you need to do it while your concrete is fresh, same day. And then later on, we come back and fill the arrows with the durable paint. And put in the curves. See some concrete going in the splitter islands pretty soon. There we go. And even the stock cutting, the jointing in the splitter islands. you have to be careful there because you don't really want to go back and fix that either. So then, of course, you have all your signs. Your yield signs need to go in. The directional signs, telling people, you know, which road to take. We start to see that, and we're done. So basically, at this point here, sorry, there's a little bit of landscaping over here. I think that was being done. I see the concrete truck doing something, but you know, at this point here, we have basically all three legs open. We have vehicles coming on County Road 2. 2 lanes in the westbound are open, and then the 1 lane, and that's it. So, all right. So again, thank you. Sorry I took a little more time than what we had scheduled, but hopefully you learned something.
That's great, Peter. Thank you very much for that. We are a little bit over time, so anybody that can stick around, we will take just a few questions. And for anybody that does have to leave, the recording and the PDF presentation will be posted in the coming days on our website. So just looking at some of the questions.
They can email us some questions too, if they
yes,
would like.
Of course. If anybody wants to follow up afterwards and you can't stick around, our contact information is in all these presentations. So you can reach out to us. So let's look at a few
Are there
questions.
any questions you want to ask now?
Yes, I will ask a couple questions. We might as well because we are recording it, so people can come back and if they have to leave. So first question, I noticed in the video in the second phase that there appears to have been a slab replaced. Was there a reason for that? It was in the area where the portable sign was sitting.
Okay, well, that's a pretty sharp eye looking at that video. I do remember there was one panel that had to be replaced. It was in the, I guess, the southwest corner across from County Road 2. And what had happened was the joint layout really wasn't the best. And we should have put in a Mercedes to give 3 legs to the joint layout, and it only had 2. So again, one of the things you learn about joint layout on concrete is you don't ever really want to see an exterior corner. You know, like Tim pointed out on the catch basin, you know, when you have the exterior corner of that catch basin, you're going to get a crack propagating off of that. Well, our joint layout for the panel actually had an exterior corner, which was a mistake on our part. So sure enough, it cracked. And we wanted it repaired. Actually, now that I think about it, I think that's what that concrete truck was doing at the end of the video. So we wanted that concrete panel replaced before we opened it up. And we corrected the joint layout, and we haven't had a problem since.
Okay, perfect. There's a comment about the flow-through jointing pattern. It says, as a roundabout designer, I recommend against the flow-through jointing pattern because drivers on the, according to drawing shown, north-south direction may follow the joints and not the pavement markings and enter the roundabout without yielding to circulating traffic.
Yeah, I would agree with that. I think when we look at the two layouts, the isolating the circle in the middle is the preferred, because that way, as vehicles pull up to the yield blocks, they also have a joint in front of them which runs parallel to the yield blocks. So that actually is, I think, the preferred design. And from a constructability perspective, we probably paid a little bit of a premium because, you know, you have these short lengths of concrete pavement that are being constructed. So you're constantly moving the paver back and forth. You're going to add a few working days. That's true. But in the end, you get a better product. So I would agree with that statement.
Okay.
Yeah, it's just easier for the other one, but I agree too. I like the circular isolation.
Yeah. Okay. And just the last question we'll address: has continuous reinforcement been used on any of these roundabouts?
The presentation. Oh, go ahead.
No, what was the question again now?
Has continuous reinforcement been used on any of these roundabouts?
No.
No, in the presentation made by Eric Furby in ACPA yesterday, they gave an example of continuously reinforced concrete roundabout, and it was in the Netherlands, I believe. There's none in the U.S. And none in Canada, but they gave that example that there have been some done, but it's in Europe where they've been done.
Okay.
Yeah. The only thing we did on the County 22, you rely on your load transfer baskets, and we were about it was on the west side, on the south side as well, and there was a bell manhole. So one of my concerns is that, when you have a bell manhole in the middle of a concrete pavement, the trench below it could be a problem. So what we did in that one, I think there was 1 or 2 panels adjacent to that bell manhole. We did put some additional 10M running in both directions. So those 2 panels would probably be the closest we had to a reinforced concrete, but it was mainly because we didn't want to see those panels cracking due to the bell trench, or the utility, I shouldn't say bell, the utility trench down below. So that's something you have to look at. Again, it requires a little bit of thinking. You gotta put your thinking cap on when you're looking at these.
Okay. And I did have another municipal representative reach out to me recently about rehabbing an existing asphalt roundabout to a concrete roundabout. So what is the main piece of advice you would give any other municipality if they are looking to use concrete roundabouts?
Well, I think in converting the asphalt to concrete, I think number one, it makes sense because of the amount of turning movements you have, the side friction. The best advice I give to you is you need some common sense, because you're going to end up with some scenarios where you say, okay, my concrete curbs are already in. So for example, when we look at the County 22 roundabout, the single lane paver was used, and then the curbs were added to the pavement. But when you're converting, your curbs are already there. So you need to infill everywhere. So you're probably going to end up with a motorized street, right? And then again, your joint layout, like I said, you might not have a perfect scenario. So you might have to put a bond break, like Tim mentioned. And that's again where you have to have a little bit of common sense to set it up to succeed. You have to look at those things. But yeah, it can be done.
Okay. Again, thank you, gentlemen, very much for your time and your expertise. This is a great overview, especially tying in with that ACPA presentation that happened yesterday. Any other final comments you guys have for our viewers before we end it?
If you need assistance, just let us know. You can give Alan, I'll speak for you, give you a call or give me a call, Tim. And I'm sure Peter would be able to give some advice. And also take a look at the ACPA one. If you're really looking at the jointing side, they went in great detail on the jointing. That use different methods of jointing other than the 2 that we talked about as well. And they talked about when you got 3 joints coming in together, you can actually put you put a hollow area in there and you infill that so that you can't have the joints jump from one panel to another. It was a very interesting presentation. So I'd highly recommend looking at that as well. The 2 really go hand in hand with each other.
Mm-hmm.
Yeah, again, I want to thank you for the opportunity today. And I agree with Tim. If there are any questions, send them through and I'll find someone to answer them for you.
Amazing. Thanks again, guys. Next webinar, December 2nd, Tim and I will be back. We decided to stop with the case studies for now. We want to switch gears a little bit to concrete pavement design. So Tim will be showcasing some of the software available, some of the inputs. We will have design examples available. So that's going to be on December 2nd, and the registration will be up in the coming weeks. So thank you, everyone. Thank you, Tim. Thank you, Peter. And have a great day.
Thank you. Thanks, Alan. Thanks, Peter. Bye now. Take care, everybody. Be safe.
You're welcome.